The aim of this tutorial is to show you how to use the addition formula. We're going to start off with these two addition formula, sine alpha plus beta, and that can be expanded to sine alpha cos beta plus sine beta cos alpha. So it's another way of writing this. You can write it like that. And also with a negative between the alpha and the beta. It's exactly the same, except you notice that this is a negative here, whereas this was a positive. Okay, sort of examples that you could get asked to do with the addition formula is one like this. You could say, find the exact value of sine 75 degrees. Okay, so we could put that into the calculator to find out the exact value, but we could also do it using the addition formula. So for example, we could rewrite sine 75 as sine 45 plus 30. And the reason why we use 45 and 30 is because we know the exact values for the sine of 45 and the cos of 45, and also for the sine of 30 and the cos of 30. So if we expand this out, we can write down the sine. So we've got here the sine of alpha plus beta. So it's the sine alpha cos beta. So sine of 45 cos of 30 plus the sine of 30 cos of 45. Right, is this working now? Yeah, it's still working again. I had a little bit of a pause there while someone came into the class, but where was I? Okay, so now we've expanded that out. We can see we've got the exact values here of sine 45, cos 30, and so on. So we can write those down. So the exact value of sine of 45 is 1 over root 2. The exact value of cos of 30 is root 3. Yep, that's right, root 3 over 2. The exact value of the sine of 30 is a half, and the exact value of the cos of 45 is 1 over root 2. So we can multiply these together, and we end up with, what's that, 1 times root 3 is root 3, and that times that is 2 root 2. And we're going to add on 1 times 1 is 1 over that times that is 2 root 2. And if we add those two together, we end up with root 3 plus 1 over 2 root 2. Oops, this is going over off the page here, 2 root 2. And that is the exact value for this sine of 75. Now, another sort of question you could get asked, and these ones are a little bit harder now. I'll just write down a question and then I'll show you how to do it. Okay, in this question you're given two right-angled triangles, and there's two angles marked P and Q. And what I want you to work out is find the exact value for the sine of Q minus P. So the first thing you want to do here is, again, you want to expand this. So we can rewrite that as sine of Q cos P minus the sine of P cos Q. Now we don't know the values for sine Q cos P or anything like that, so we've got to work them out. And if you think back to your days doing trigonometry, you'll remember that this right angle triangle, if this is the angle, this side will be the opposite. If this is a right angle, this side here will be the hypotenuse. And if this side is adjacent to the angle, that will be the adjacent. So for this triangle here, we can actually write down all the different values of Q. For example, we could work out the sine of Q, So let's write that just over at the side. In fact, let's just do it down here. What about that line there? That equals. So the sine of q is the opposite over the hypotenuse. The opposite is root 3. The hypotenuse is 4. So we can write down root 3 over 4. So that's the exact value for the sine of q. Now notice here we've also got the cos of q. So we're going to have to find out the exact value for the cos of q. And the cos is the adjacent over the hypotenuse. But the problem here is we don't have the adjacent. And the way to work out the adjacent is by using a little bit of Pythagoras on here. To work out this side here, you're going to have to square the hypotenuse, and you take away root 3 squared. And we've got to do the root of all of that. So that's going to give us 16, take away root 3 squared is 3, so it's going to be 16 take away 3, which is going to give you the root of 13. So that adjacent side there is root 13. So we can write down here the adjacent is root 13 over 4, which is the hypotenuse. So there's the exact values for the sine of q and the cos of q. We've got to do exactly the same for this triangle. So that means we're going to work out what the sine of p is going to be, and also what the cos of p is going to be. So again, we can label the sides opposite, hypotenuse, and then the adjacent. And again, we can work out the adjacent by squaring this side, which will be 2, take away 1 squared, so it's going to be 2 take away 1, which is going to be the root of 1, which is 1. So that's going to be 1 as well. Sine of p is the opposite over the hypotenuse, which is 1 over root 2. 1 over root 2. And also the cos is adjacent over the hypotenuse, which is going to be, again, 1 over root 2. So now with all this information, we can substitute all this into this addition formula here, or the expanded bracket. So sine q, there's sine q, is root 3 over 4. Cos p is 1 over root 2. And we're going to take away sine p, there's sine p there, and times it by cos q, which is this one here. You can't see any of that. I'll see that all again. That's annoying. Right, okay, so as I was saying, you can now substitute these values in. The sine q can be replaced by this number here. So I've done that, root 3 over 4. The cos p can be replaced with this exact value over here, which is 1 over root 2. And there I've replaced it with 1 over root 2. Sine p, again, is 1 over root 2. So I've replaced that there with 1 over root 2. And last, cos q, the exact value of cos q is root 13 over 4. Now I've just got to tidy this up a little bit. So root 3 times 1 is root 3 over that times that is 4 root 2. And then this one here is going to be 1 times 13 is 1 over 13. And again, that times that is 4 root 2. And you end up with root 13, take away root 3, oops, wrong way around, root 3, take away root 13, all over 4 root 2. So that's the exact value of sine of q take away p. And you could work out what that angle is, q take away p, by doing the inverse sine of this, and that will give you what the answer is. But it does not ask for that. Okay, so I hope that helps you with the addition formula using or expanding sine of alpha plus beta and also sine of alpha minus beta.